Sip 9 Hub. Hi, welcome to the first episode of this channel. For today's video, we will be talking about patterns as it relates to mathematics. This is one of the first few lessons included in the new course called Mathematics in the Modern World, taken by Filipino college students. But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos. The ability to recognize patterns is an important skill. Studying patterns helps people identify the relationships and logical connections of things that would then allow them to generalize or predict events. In fact, pattern recognition is integrated in our everyday activities. For example, you notice that your internet connection becomes faster at nighttime than in daytime based on an observation of your internet connectivity for the past 5 days. The changes in your daily routines becomes more evident because it is a change that has become a pattern or a repetition for months now due to the effects of the COVID-19 pandemic. In mathematics, pattern recognition is a vital skill that needs to be developed among students. And having said that, let us initially test your pattern recognition ability with the following slides. You will be presented a pattern and your job is to predict the next element. Of course, you may pause the video if you need more time. Let us begin. For 5 seconds, what is the next element? This is a bit easy for you, I believe. The answer is a blue circle. Another one, still for 5 seconds. Yes, the answer is a yellow rectangle. Let's move on with another one. Still for 5 seconds. To answer this pattern, we first observe the images here at the top portion. And if we look at these images, the image at the upper right side is just an inverted version of the image in the upper left. So if we follow that pattern, we simply invert this image, and that is option B. Another one for 10 seconds now. Let me click the timer first. And time's up. How do we answer this one? We see in the first row that among the 3 figures here, one of them is shaded. The same with the figures in the second row. One figure is shaded, that's a square. And if we follow that, in the third row, one should be shaded as well, and that is option B. Another question for 10 seconds. Time's up. Let us again compare the images here, the given image. At the upper right, it seems that this is just a rotated version of the image here, the upper left. So if we're going to rotate it counterclockwise, then the answer should be option B. This is, I believe, a bit harder, more difficult question for 15 seconds. Time's up. We have here pictures of polygons, actually pairs of polygons, and for each pair we have an unshaded polygon, and then inside it is a shaded one. That's true to all the pairs of polygons here. Let us investigate the kind of polygon that we have here for each pair of polygon. So in the first image, you have a triangle or a three-sided polygon, and inside it is a shaded square. A square is a four-sided polygon. In the next figure, you have a four-sided, a quadrilateral or a four-sided polygon, the unshaded one, and inside it is a pentagon or a five-sided polygon. And the other one, the unshaded polygon, is a pentagon, and inside it is a hexagon or a six-sided polygon. We notice that for each pair, the polygon inside has one more number of sides than the polygon outside, 3, 4, 4, 5, 5, 6, so that the next pair of polygons must be a six-sided outside or a hexagon, and inside it is a pentagon or a seven-sided polygon. Here is the last question for 15 seconds still. Let us observe the following image and identify the correct element here. Time's up. Okay. It seems that the figures here are like seesaws, and these seesaws are balanced. That is obvious for the first two pictures here, because we can see that we have the same kind of shape and then the same number. For example, you have one circle at the right side of the seesaw and then another one at the left. So that's certainly balanced. That's the same with the second one, two squares at the right side of the seesaw and then another two at the left. The third figure is an information telling us that the square at the right side has the same weight with two circles. So one square balances off with two circles. Similarly, for the fourth picture here, a triangle has the same weight with two squares. So the question is the same as identifying which of the seesaws here, 5 seesaws here, gives a balanced one. For the first option, that is not correct because it's not balanced, and for reason that it violates actually this image, the fourth one. One triangle has the same weight with two squares. So if you add one circle here, then it makes it unbalanced, so that cannot be the answer. Option B also is not the correct answer because a triangle is equivalent to two squares. If we want this balance, then since one square is equal to two circles, you'll have to add another circle here. That's incorrect. Letter C is also incorrect because a triangle must be of the same weight with not 3 circles but 4 circles, based from a deduction that since a triangle is the same as or has equal weight with 2 squares and each square has equal weight with 2 circles, then a triangle must have the same weight with 4 circles. We see now that the correct answer is letter E. That's what we've been talking about. That's the balanced one. Letter D is still not the correct answer for the same reason that the seesaw is not actually balanced, that one side is heavier. And it's up for you to figure now why is that. All these exercises that we answered are examples of a pattern. A pattern is almost anything that repeats. Some would describe it as a regularity in the world because it does not just happen once and coincidentally, but happens repeatedly. Natural or human-made, patterns are everywhere and are encountered every day. From the layout of the floor tiles, the design of fabrics or textiles, the blocks played by kids, the arms and leg movements in an exercise, to the arrangement of books in a library. Now, I will be presenting to you the different types of patterns that we learn in mathematics. The first type of pattern that we will be talking about is called the number pattern. By the name itself, of course, this suggests that it is a pattern involving numbers. In mathematics, a number pattern is more popularly known as a sequence. It is just a fancy term for a number pattern. The first number that you see in a sequence is called the first term. The second number is the second term. The third number is the third term. You get the point. Let's provide some examples of it. Here is our first example of a number pattern or a sequence. It is a sequence whose first term is 1, second term is 4, third term is 9, fourth term is 16, and fifth term is 25. The character that we see here is that read as ... but that is actually called an ellipsis, and that indicates that the sequence is rather progressing indefinitely. That means that the number of elements in our sequence is infinite. If we're going to identify the sixth term, because we can see that the fifth term is already 25, so we're going to identify the next term, that's the sixth term. We cannot just guess. We need to explore, to review, to observe what is happening there. What is actually the pattern? Why is it called a number pattern? So how should we do that? Now we observe those kinds of numbers. What kind of numbers are these? 1, 4, 9, 16, 25. They are actually perfect squares. For example, 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and 16 is 4 squared. Also, 25 is the square of 5. So that the sixth term must be the square of 6, which is equal to 36. Here is our second example of a sequence. Its first element is 1, second term is 0, and the last term is 1. As opposed to the example we provided in the first example, this is already a finite sequence. It has 13 elements, and our goal here is actually to find for the missing element. That is, I believe, the 10th term. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it's the 10th term. And in order for us to do that, let us observe the pattern that really happens here. So what is that pattern? Well, we see that the first and the last terms are both 1. They're the same. Also, the second and the second to the last term are the same. The third and the third to the last term are both 3. The fourth and the term from the last, fourth from the last, are both 9, and so on. So we see here that the numbers here are actually the same with the numbers at the last portion of the sequence, so that the element that completes this sequence must be 8. The sequence that we see here is an example of a palindrome. A palindrome is simply a number or a sequence of numbers that reads the same forward or backward. So actually, if we rewrite this, sequence starting at the last term, we would have the same sequence. Alright, so let's have another type or a kind of a sequence here, a special sequence. It's called an arithmetic sequence. This is a sequence in which if you're going to take any two consecutive term, the difference is always the same. Let's consider the following example. So you have a sequence here whose first term is 2, the next one is 4, 6, 8, 10. Why is this considered an arithmetic sequence? That's because if we're going to take the difference of any two consecutive terms, for example 2 and 4, the difference is always the same. So the difference between 2 and 4 is 2. The difference between 4 and 6 is again 2. The difference between 6 and 8 is again 2. So actually it's the same for any two consecutive term. That the same number 2 that we always get is called the common difference D. So the value of D is 2. D is just a representation of the common difference. Let's have another example of an arithmetic sequence. Is this a valid arithmetic sequence? Let's check. The common difference must be the same all throughout. So the difference between 5 and 10 is 5. That of 10 and 15 is 5. 15 and 20 is again 5. 20, 25. Their difference is 5. So the common difference is equal to 5. How about this one? Is this an arithmetic sequence? Let's see. What is the difference? 0 minus 3, that's negative 3. Negative 3 minus 0, again negative 3. So actually it's always negative 3. So yes, this is an example of an arithmetic sequence. And the common difference is negative 3. Well, of course, when we subtract two consecutive terms, we start with the latter term. We subtract it by the former term. Let's have another type of a sequence. It's called a geometric sequence. And for this sequence, when you're going to take any two consecutive term and divide it, the quotient or the ratio is always the same. Let's have this sequence as an example. Why is this considered a geometric sequence? That is, if we're going to take any term and divide it by its preceding term or the term before it, the answer is always the same. For example, 6 divided by 3 is 2. 12 divided by 6 is again 2. 24 divided by 12 and 48 divided by 24 are both 2. We say that 2 is the common ratio of this geometric sequence. How about this one? Is this a valid geometric sequence? Let's see. Let's check. We start with 9. 9 divided by 3 is 3. And if we continue with the other terms, we will see now that the answer is always 3. So yes, this is considered a geometric sequence and the common ratio is 3. Another one, is this a valid geometric sequence? Well, if we divide 50 by 100, that is 1/2. We divide 25 by 50, that is again 1/2. And 12.5 by 25 is 1/2. So yes, these are all valid geometric sequence. And the common ratio for the last geometric sequence is 1/2. Here is another type of a sequence. It's really a special sequence. It's called the Fibonacci sequence. And it's a sequence such that each term that you're going to identify is actually the sum of its two preceding terms or the two terms before it. For example, 3 is the sum of 1 and 2. 5 is the sum of 2 and 3. 8 is the sum of 3 and 5. 13 is the sum of 5 and 8. 21 is the sum of 8 and 13. So if we want to continue this pattern, our answer must be the sum of 13 and 21, which is 34. This is the definition of a Fibonacci sequence. Let me cut the video here. For the other kinds of patterns, I will see you in the next video.